In this lesson, we're going to look at solving linear inequalities. This is actually a lot or very similar to solving equations. The only difference is rather than an equal sign, we have a greater than or less than sign in the middle. So let's take a look here. When the same number is added or subtracted from each side of an inequality, the resulting inequality is still true. So 3 is less than 7. Yeah, we would all kind of agree with that. Then if I add 1 to both sides, I'd get 4 is less than 8. Yeah, that's also true. Or if I subtract from both sides, here I get minus 3 is less than 1. That's true. So that's no problem. If I multiply both sides by the same number, so here if I multiply both sides by 2, I'll get 16 is greater than 6. That is also true. However, if I multiply something by a negative, or if I divide something by a negative, you'll see what happens here. 8 times negative 2 is negative 16. 3 times negative 2 is negative 6. This is not true. This is not true, right? Negative 6 is greater than negative 16. So to overcome this, we have this following rule here. When each side of an inequality is multiplied or divided by a positive number, the resulting inequality is true, so that's fine. However, when it's multiplied by a negative, multiplied or divided by a negative number, the inequality sign must be reversed. So when it's by a negative number, we have to switch the inequality sign. So that negative 16 and minus 6, I should have negative 16 is actually less than negative 6. That's pretty much the only thing you need to really remember when dealing with inequalities as compared with equalities or equations with equal signs. So let's practice some of these on the next. Again, I'm going to try to get my x term by itself. So I'll subtract 1 from both sides. And I'll get 2x is less than 2. Then I'll do the opposite. Here it's being multiplied, so I'll do the opposite. I'll divide by 2. And I get x is less than 1. So you'll see I use my same rules when I'm trying to isolate my variable. And because I didn't multiply or divide by any negatives, I didn't have to flip the sign at all. And the sign stays the same, okay? So if it's less than or greater than, you leave it there. You don't ever add or take away this bottom line, meaning equal to. Let's try the next one. I'm going to add 7 to both sides. That'll get rid of this term. And I'll have 6x is less than or equal to 15. Then I'll divide both sides by 6. Divide by 6. And I'll get x is greater than or equal to 15 over 6. Or I could say x is greater than or equal to 5 over 2. Both of those would be fine, but I always prefer the reduced fraction. Again, I didn't multiply or divide both sides by a negative, so the sign stays the same. Alright, let's do this next one. I'm going to subtract 2x and bring this one over. So I'll get 3x plus 1 is less than minus 7. Then I'll bring the negative 1 over here. And I'll get 3x is less than negative 8. Divide both sides by 3, divide by 3. X is equal to negative 8 over 3. Alright, let's try this next one. Again, I'll minus x. I'll bring my x terms together. So I'll get 3x plus 2 is less than or equal to negative 10. Then I subtract 2, 3x is less than or equal to negative 12. Divide by 3, divide by 3. And I'll get x is less than or equal to negative 4. Now none of these did I multiply or divide by a negative number, so I don't actually have to flip the inequality. That'll come up on the next page. Alright, let's try this one. This is a one-step one. I divide by 7, divide by 7. And a is going to be greater than -3. Now this one, I'm dividing both sides by -5. Okay, dividing by -5. So s is going to be, I have to flip the sign. So s is now going from less than or equal to greater than or equal to. And 25 divided by -5 is -5. This one I'm going to multiply both sides by -4. So I'm going to get y. I have to flip the sign because I multiplied by a negative. Is going to be less than 12. -3 times -4 is going to be 12. And this one here, I multiply by 3. Multiply by 3. And I'll get k is greater than or equal to -6. Now I only switch the sign when I'm multiplying or dividing by a negative. It doesn't matter if my answer ends up being a negative. That's not important. What is important is whether or not I am multiplying or dividing by a negative number. Let's do a couple more on the next page here. So here again, I always move my smaller variable term just so that I'm dealing with positive variables. 3x plus 4. And then I'll -4 from both sides. -4. And I'll get -3 is greater than 3x. Divide both sides by 3 to get x by itself. And, oops, I'll do that in blue. X is, I should start with -1 is greater than x. Now you'll notice my pause there, right? When I'm doing an equal sign, it doesn't matter which one goes first. But when I'm doing an inequality, it does. So if I was going to switch these around and I had x on the other side, I'd have to flip that. Because x is less than -1, or I could say -1 is greater than x. So if I'm switching which side the x is on, I do have to switch the sign. That's just a little note there. Okay, this one, add 5x to both sides. I'll get 2, computer glitch. 2 is greater than or equal to 12x plus 1. Whoops. Subtract 1 from both sides, subtract 1. And I'll get 1 is greater than or equal to 1 is greater than or equal to 12x. And divide both sides by 12. Divide by 12. And 1 is greater than or equal to, 1/12 is greater than or equal to x. And again, if I wanted to switch that around, I could do that. I would get x is less than or equal to 1/12. Those are both fine. All right, let's try the next one. This is the last one, and this kind of combines all the things we've been doing. So we're going to do the distributive property first. I'm going to simplify both sides as much as I can, and then I'm going to do my algebra. So I'll get -2x minus 2, when I multiply those over, is less than 3x minus 6. So I apply these coefficients to everything inside the brackets. Now I'm going to bring my 2x over. -2 is less than 5x minus 6. Add 6 to both sides. I'll get 4 is less than 5x. divide by 5, and I'll get 4/5 is less than x. Or if I wanted to switch that around, I'd get x is greater than 4/5. And that ends the lesson for today.